Okay, good afternoon all. So last time we had done lines plan, the body plan part. We'll do the theory part and explain what is lines plan now. So line plan are the projections of intersection of hull with the various planes here. So the planes, as I said, was transverse, which is 90 degrees to your hull, or longitudinal, or horizontal. So the planes are equally spaced in each of your three dimensions. They are mutually perpendicular or orthogonal to the hull. So the point of intersection of these planes will create the lines here, and the lines when projected on single plane will show you the front side in your, this is body plan. So the top side will be in your half breadth plan and the side view will be your shear plan. Now with these kind of projections, you have three types of plans, which is body plan, which is the front view, half breadth plan, which is the bird's eye view, and shear plan, which is the side view. So how do you visualize it? Like you have your rectangular box where your sides are touching the keel and sides of the ship, or you have a barge. So the barge basically, if you have a barge here and you cut the barge into the various shapes here, you'll not get the curved line which you get it in the ship. I just explain with the barge. This is your barge. Now suppose we are making orthogonal planes here. So one plane is cutting like this, it's cutting like this. Section is cutting like this. So similarly others are cutting. So in the body plan, if you have, the shape will be like this only, like a box. You'll have this shape only all the time because there are no curves. If the block coefficients are there, if there is a yacht, so if the yacht is there, then your curves will be it'll be more curvy. If the this is like, no, this is there. So if it's a yacht, then it'll be more curvy like this. It'll be, the distance space will be more. The yacht, it will be very openly spaced like this. But if it's a VLCC, then your body plan will be somewhat, just tell you how it will be. So it's a VLCC, and suppose you have the shear will not be that much in the VLCC. So in a VLCC, the curves will be less, they'll be like this. Very less curvy because the block coefficient is more. So the plan will be like this mostly because it's a very long ship where the midship section is very long. So VLCC, if you have, most of the area will be a block coefficient because it's coming to 0.85. So the midship area here will be very long as compared to the forward section and aft section. So the forward section, if you see, you have a side view. If you see, the vessel will not be having too much of shear. It will be like this. In a VLCC, if you go, you'll not have the deck will be continuous from forward to aft. You'll not have a raised forecastle deck here. It will be like this. and aft section you will have the accommodation here. So the main area here will be quite large. So the body plan will be somewhat like this. So it depends what kind of block coefficient the vessel is. Accordingly, your body plan will be shown. So if you see, as I had explained last time, you're cutting the various athwart ships into one. Number one will be for 0 will be half perpendicular, forward will be 10, suppose. So 11 sections are there. So this will be a midship section where the largest curve will be there. Forward and aft curves will be small, those projections. Like this, you have supposed 11, so the curves will be like this. So this is 0 and that is 10. And the various sections, what curve they are making with the hull, these planes, that is projected. Aft end is here and forward end is here. So body plan, your planes parallel to the front and back of the imaginary box are called stations. And there are three important stations. So one is your forward perpendicular, where your stem is cut by a perpendicular line at the saltwater line. And then you have aft perpendicular where your rudder stalk, middle of the rudder stalk, the line perpendicular is passed. So that is another station. And then you have a midship station, which is important between the forward and aft perpendiculars. So here you have 5 stations if you see. Forward, aft station, forward station and midship station. So you can have 5, you can have 11, 10, you can have 11, or you can have 21, depending on how much is the curving required. So here is your, as I had explained, the shear is there. Foxel is twice the shear and foxel is twice of O. That's why this is raised. So number 10 is your aft is your forward perpendicular and 0 is your aft perpendicular. Accordingly, it's being done here till 5 and 5 and 6 are midship areas, and then the forward curve is coming up, and the horizontal lines are the waterline planes. So ship is normally divided into 11 or 21 stations from aft perpendicular, which is station 0. So wherever your curves are more, you can have half or even quarter stations. And since most ships have symmetrical shape for both port and starboard, you see only one side in the drawing. Normally we take starboard side. So standard practice for showing stations of the aft region will be on the left side of the body plan. The right side will have from midship till forward perpendicular. So the curve on the body plan is also known as station curve because the curves of the stations are projected here. The center line represents the center line of the ship. So here the body plan is also showing the water lines and buttock line grid. And these grid lines are essential not for reference line, but you're transferring the data from one plan to the other. So how they transfer from one plan to the other. Let's see if the drawing is here. Yeah. So if you see, this is the half breadth plan project or your body plan projected here with half breadth plan. So this is transferring of planes. Here, these are the waterline planes transferred to half breadth plan. And I'll explain once we come to the half breadth plan how the body, these water lines are cut. So apart from showing the station curve, the body plan will also show the waterline and butterline grids. So they are used for transferring and checking data from one plan to the other. So the station plane is intersecting the ship's hull and forming curved line at the points of intersection. And these lines are called sectional lines, and they all projected onto a single plane called body plan. Now we come to the shear plan. So the plane that runs from out
क्योंकि पहले तो ऐसा ही होता था ना कि हम लोग मतलब सब हमेशा एंड में करते थे।
माइक बंद कर दो।
उनको पता नहीं थी, उनको लगता
Now we come to the shear plan. Now in the shear plan, your planes which are orthogonal or which are perpendicular to the ship's hull, they're cutting the ship into from longitudinally into various sections. So you start from midship. You're starting from the center line, not midship. Center line towards the starboard side. So center line, the curve coming here will be projected like this. When you're coming towards the starboard side, the curve will become shorter. Show you how. So the red line is actually on the edge, starboard edge, and the green line is the first line is basically the center line. So you see the profile of the ship here. Then the next line to the starboard of the center line, the longitudinal plane. How it is cutting the hull will be shown on the green line. And the next line, the plane which is cutting the hull will be the blue line. And then the red line which is towards the ship side, starboard side. So this becomes your shear plan. So here you can see the shear plan. So this line is showing the edge, starboard edge, while this line is the center line. So when it is cutting in the center, you get the full profile of the ship, and then equidistance from center towards the side, the longitudinal planes are cutting the hull at right angles or orthogonally. And then you have these lines coming up, and these lines with the hull is making with the plane is known as buttock line. So here this is projected on a 2D plane. There you see the buttock line. So you see the shear plan. You've seen all these plans on your boards on the ship, but you've not understood what it is. So this is your body plan, this is your shear plan, and this is half breadth plan. All three are lines plan. They are 2D scale representative or 3D complex form, which is described with geometry. Any questions on shear plan and body plan so that we enter the half breadth plan theory? Any questions on shear plan?
एक बार शेयर प्लान में जो लाइंस ड्रॉन है ये सिर्फ स्टारबोर्ड साइड की होंगी कि इन दैट 2D प्रोफाइल यू शोन थ्रू
स्टारबोर्ड साइड की है। मैं फिर से दिखा देता हूँ क्या है। पोर्ट साइड की हम नहीं लेते हैं, फिर से मैं आपको बताता हूँ क्या है। सपोज दिस इज द शिप, ये आपका शिप है, ठीक है, और ऐसा स्ट्रक्चर बना दिया, ठीक है। अब मैंने एक प्लेन बनाया विच इज ऑन द सेंटर लाइन। सेंटर लाइन से मैंने प्लेन पास किया। तो जब सेंटर लाइन से प्लेन पास किया, सपोज यहाँ सेंटर लाइन से पास किया, तो जो कर्व आएगा बाहर, सपोज एक ये बॉक्स बना है, बॉक्स में मुझे लाइन प्लान बनाना है, तो कर्व क्या आएगा? कर्व बाहर वाला सेंटर का आएगा। ये सेंटर का रीजन ये कटा है ना, ये रीजन कट गया है, इट इज कटिंग द सेंटर लाइन, ठीक है। तो सेंटर लाइन में योर ये प्लेन आ गया ऐसे, तो ये प्रोफाइल व्यू हुआ, ठीक है, जो सेंटर लाइन में कटा। अब मैंने एक और सेक्शन लिया विच इज टुवर्ड्स द स्टारबोर्ड साइड, तो मैंने एक और सेक्शन ऐसे काटा, सपोज ये वाला काट दिया। अब इसने हल के साथ क्या शेप लिया? व्हाट शेप ऑफ द हल इट इज टेकिंग, वो थोड़ा सा अंदर आएगा। तो सपोज मैंने एक और कलर ले लिया, ऑरेंज करके ले लिया, चलो, तो थोड़ा सा वो अंदर की तरफ आया तो ये ऑरेंज हो गया ऐसे, ठीक है, यहाँ से आ गया ऑरेंज। अब मैंने एक और प्लेन काटा थोड़ा सा स्टारबोर्ड, मैं यहाँ से यहाँ मूव कर रहा हूँ, ठीक है, सेंटर लाइन से यहाँ की तरफ मूव कर रहा हूँ। अब मैंने नेक्स्ट प्लेन लिया, सपोज मुझे लेना है ब्लू, तो मैंने एक ब्लू सेक्शन काटा यहाँ से, ठीक है, ब्लू सेक्शन काटा, तो वो हल के साथ क्या शेप लिया, तो ब्लू का सेक्शन लिया, ब्लू सेक्शन अब दिखा रहा हूँ कैसे, तो ब्लू सेक्शन ये यहाँ से ऐसे आ गया, थोड़ा सा इसको घुमा देंगे, हल्का शेप ले रहा है। तो जो एज पे आएगा, सपोज आखिरी वाला आ रहा है या यहाँ आ रहा है, सपोज ये ग्रीन कलर लिया आखिरी वाला, तो आखिरी वाला जो है दैट इज कटिंग इन द एज हियर। तो जो शेप लेगा वो यहीं का लेगा ना, यहाँ से यहाँ का लेगा स्टारबोर्ड का। तो नाउ दैट शेप विच विल कम विल बी द एक्सट्रीम स्टारबोर्ड एंड जो यहाँ कटा, तो सपोज यहाँ से कट गया तो इट विल बी लाइक this. So you are getting the shape of the hull from the side view. So you are looking from here, from the side here. जब हम बॉडी प्लान बना रहे थे, we were having this view. बॉडी प्लान जब बना रहे थे हम फ्रंट व्यू ले रहे थे, लेकिन shear plan में taking the side view. So we are getting like this shape. The shape of the hull or the planes which are cutting longitudinally. Have you got it now? अब क्लियर है कि नहीं है?
जी सर, थैंक यू।
ओके
सर इनका यूज क्या होता है सर प्लान्स का?
बेटा, ये प्लान का ये यूज है कि आपको पता लग जाएगा कि कर्व कितना हो रहा है किस व्यू से। अगर आप इंजीनियरिंग ड्राइंग करोगे ना, तो इंजीनियरिंग ड्राइंग में आपके व्यूज होते हैं, सामने से क्या व्यू है उसका, एक शेप का, फ्रंट व्यू क्या है, टॉप व्यू क्या है, साइड व्यू क्या है, तो वो ये व्यूज दिखा रहा है। अब उससे क्या है, विद द व्यूज यू नो दैट कर्वेचर क्या है, और जब 3D मॉडल इससे बनाएंगे तो एग्जैक्टली यू नो कि कहाँ कर्वेचर आ रहा है। तो नेवल आर्किटेक्ट्स हु मेक द 3D मॉडल ऑन कंप्यूटर्स दे नो एग्जैक्टली व्यू से कि आपका बार्ज है, बार्ज में तो कोई व्यू ही नहीं है ना, बार्ज का तो बॉक्स है, बट हियर यू हैव अ कर्व बिकॉज ऑफ योर ब्लॉक कोएफिशिएंट। तो कर्वेचर आपका कैसे है, इफ यू हैव अ फ्रंट व्यू तो हल कर्वेचर कैसा रहेगा, इफ यू हैव अ साइड व्यू तो हल कर्वेचर कैसा रहेगा, इफ यू हैव अ टॉप व्यू so how will be the bottom of the ship, how will be the side of the ship, how you have a front view तो कैसा shape होगा। so giving the shape will be there। अभी हम जब मॉडलिंग करेंगे then you will understand। एक वायर फ्रेम मॉडल आएगा, एक सरफेस मॉडलिंग आएगी, 3D मॉडलिंग आएगी, उन सब चीज में ये लाइन प्लान यूज होगा, ठीक है। बिकॉज इफ यू मेक इट इन अ प्लेन, आपको कैसे पता लगेगा कि कितना कर्व है। सो अगर आपने ये प्लान देखा तो आप विजुलाइज करना शुरू हो जाएगा, कर्वेचर यहाँ से शुरू हो गया, यहाँ एंड हो गया, इसके बाद कर्वेचर नहीं है, यही कर्वेचर है, उसके बाद कर्वेचर नहीं है। लेकिन अगर एक यॉट होगा उसका कर्वेचर यहीं तक चलता रहेगा। सपोज यॉट इज देयर, एक यॉट है सपोज, ठीक है, तो अब यॉट का कर्वेचर लेंगे, तो यॉट का कर्वेचर सपोज इधर से आया, लंबी यॉट है तो एक कर्वेचर दूर दूर तक आएगा यहाँ से। अब आप समझ रहे होगे कि कर्व कितना है, देन आपका ये कर्वेचर आएगा। सो इसका मतलब कि उसका काफी कर्वी है। अब यहाँ कितना कर्वी नहीं है, यहाँ ज्यादा कर्वी है। सो नाउ यू नो हाउ मच इज द कर्वेचर है, तो कितना वो बाहर निकला हुआ है। इसको अगर आपने सोचा कि जैसे हम बचपन कहते थे ना, इसको खींच लो कागज को तो आपको उसका शेप पता लग जाएगा। So if you pull this paper like this, अगर पेपर अलग अलग कलर का इसको बाहर खींचोगे, if you pull it outside, you will get the shape of the ship, जिसको कहते हैं पेपर क्विलिंग करके। तो वो आप इसको पेपर में ऐसे दबा के खींचोगे तो आपको शेप मिल जाए। तो सिमिलरली इस टाइप का you get a shape of the ship with these plans। visualization will be more effective rather than just a plain ship. क्योंकि शिप को हाइड्रोडायनेमिकल बनाना पड़ता है तो उसके लिए उसका ब्लॉक कोएफिशिएंट को बनाना पड़ता है. ब्लॉक कोएफिशिएंट उसका बहुत ज़्यादा होगा, so it will not be too hydrodynamical like your VLCC. You can't attain too much speed because it has to carry cargo. So the main aim is not the speed but the cargo. A container, the main aim is speed, not the. It is the speed there. For that reason, they have to reach about 18, 19 knots or 20 knots. तो उसको ज़्यादा हाइड्रोडायनेमिकल बनाएंगे. Now we come to the third one, which is half breadth plan. Here you have to imagine the shape, underwater shape of the hull. So for seeing the underwater shape of the hull, अब आपको दिखाते हैं कि अंडरवाटर शेप कैसे हुई. सपोज यू आर मेकिंग योर, अगर आपका एक शिप है उसको हमने उल्टा कर दिया, जस्ट फॉर योर एग्जांपल समझाने के लिए बता रहा हूँ, उसको उल्टा कर दिया और मैंने ड्राफ्ट मार्क्स का कटिंग कर दिया. ये अलग अलग ड्राफ्ट मार्क्स का कटिंग है. अब हम जस्ट एक्सप्लेनिंग, उसको इतना ऐसा लेने की जरूरत नहीं. पहले अगर ऊपर का मैंने लिया शेप तो कर्व ऐसा आया 1 मीटर ड्राफ्ट पे, 2 मीटर ड्राफ्ट में कर्व ऐसा आया, 3 मीटर ड्राफ्ट में कर्व बढ़ता गया, ऐसे 4 मीटर 6 मीटर एंड ऑल कर्व बढ़ता गया. कर्व इज मोर. लेकिन वी नॉट इंटरेस्टिंग इन मेकिंग द फुल कर्व लाइक दिस. तो हम क्या करते हैं कि एक सेंटर लाइन बना दिया और मैंने ऊपर का गैप कर दिया, यहां से गैप कर दिया, जस्ट रिमूव दैट. अब मेरा क्या हो गया, शेप विल बी लाइक दिस. तो at the depth, suppose this is 1 meter, just for example, 1 मीटर पे हमने कर्व लिया, 2 मीटर लिया, 3 मीटर, 4, every equidistant. So we're not taking the top end, we're taking the bottom end. Reason being, suppose you have a shear plan. Suppose you have a shear plan and you want to superimpose a half breadth plan on top, then you can superimpose. Suppose this is your shear plan. And we're making the shear plan like this. You can't make a body plan on shear plan, but you can make a half breadth plan on shear plan. So suppose you make a shear plan like this, I can make the body plan here on this also, like this. So I can superimpose the body plan on the shear plan. So body plan is showing what is the shape of the underwater hull. Shear plan is showing the side view में क्या shape आ रहा है. And body plan, this is half breadth plan, will be showing the underwater shape of the hull. This will be showing the shape of the side from the side view, that the shear plan, and front view will be showing the body plan, which is from the forward. So suppose you have a bottom of the box as a reference plane, that's the base plane. So the base plane is normally with the keel, making series of parallels above the base plane as imagined at regular intervals, which I'll show you here. So you're cutting horizontally at the various depths here. So these are the water lines. Here the water is cutting. So we are not taking the entire circular region or the entire water plane area. We're taking only the half of the region. So if you remove the bottom half, you get this half. You remove the top half, you get the other side. So you are cutting the planes at the various water lines to get the shape of the underwater hull. So each plane intersects the ship's hull and form a line at the point of intersection, and these lines are known as water lines. They are projected on a single plane. It will be half breadth plan. So for the water lines, you are taking the true shape of the hull. So that's a top view or some elevation above the base plane. So these are the water lines or the intersection of the ship hull with imaginary plane above the baseline. And because you're symmetrical above the center line, we need only half of that, either the port or the starboard, therefore half breadth plan. So these are basically the water lines curved here. But in body plan and shear plan, the water lines will be straight. Half breadth plan, the water lines will be curved. That's the half breadth plan of the ship. So if you see, they're transferring the lines. These are the straight lines on half breadth plan and the straight lines on body plan, which are transferred to curved lines, which are the water lines in the half breadth plan. So half breadth plan water lines are curved, while in body plan the water lines are straight. So the buttock lines are the lines used in the shear plan, and half breadth plans is showing you the underwater shape of the hull. That's why it is useful. So any questions on these lines plan?
Sir, while drawing these plans, is there any standardized number regards to outlines which we make on plans? I mean, there is number 20 outlines we can make in the
That
plan, or
depends on what kind of curvature is there. So basically, it's basically used for your architects. So the more curvature is there, so if it's a box-shaped vessel, then you don't have much curvature, so you can have the bare minimum number of lines. But if the curvature is there more, then number of lines required will be more, or number of planes required will be more. So you can have 21 lines for stations for your body plan, or you can have 11 also, depending on how curvaceous your ship is, because it's how you design the hull. So you have more number of planes, then the curvature can be designed much better. So your class can decide what kind of number of planes you're supposed to use. They might define it during shipbuilding. Okay, number of planes required will be more here. So accordingly, you'll have more number of planes there. So your class is going to decide when you are shipbuilding it.
जी sir.
Okay. So now we'll come to the next part is modeling and rendering.
सर
Okay.
ये स्टैंडर्ड पार्ट टेस्ट के नोट्स नहीं है सर हम लोग के पास
स्टैंडर्ड फाइटर्स के नहीं है, कौन सा बैच के?
सर
सब बैचेस
अप्रैल बैच सर जितने भी नोट भेजे उसमें मैंने चेक किया स्टैंडर्ड पार्ट टेस्ट के नोट कोई स्लाइड या फिर कोई वर्ड फाइल नहीं है
नहीं, स्लाइड तो नहीं मिलेगा, नोट्स तो मिल जाएंगे, नोट भेज देंगे आप।
हाँ सर कोई मतलब कुछ भी नहीं है स्टैंडर्ड पार्ट टेस्ट
मिल जाएगा, जो आपको नहीं है वो मैं लिख लेता हूँ, you'll get it today, you'll get it. ठीक है, लेट मी नोट डाउन। ये बाकी बैचेस को तो दिया हुआ है, आपका मैं लिख लेता हूँ। एनी अदर थिंग्स यू हैव तो बता देना, आई विल सेंड यू, राइट? तो लेट मी राइट डाउन phase 2. ठीक है, तो आज आपको मिल जाएगा. Now we will come to the model part. So modeling is basically, as I said, we do the modeling part to decide how much steel is going to use and all. And basic modeling is wireframe model, where your actual shape of the hull is not given. You make a series of wires here to make a wireframe model like this. So this is a wireframe modeling where you don't have actual surface there. So you don't know the depth here, but at least you can imagine, visualize where the curves are. But you don't know the surface area, how much is being used, or what is the thickness there. So you can't determine any shape from here. So this is your wireframe modeling. Second type of modeling is your surface modeling, where you have the surface but you don't have the depth there. So this is a surface modeling where you can get the surface, but you can't get the depth of the surface. So you can't find out the light shift rate and all. The third kind is your solid frame modeling, where the modeling part is you get the depth also of the ship. So you know exactly how much the steel weight is being utilized. So that is a solid frame modeling. So all these modelings are basically done for finding out about the ship part, where the structure is being used and all. So basically it is a 3D line drawing. It's not a 2D thing which you have in the line shapes, but it's a 3D line drawing to show only the edges without any side surface in between. So like you have those in some of the shops, जो बचपन में साइकिल बनाते थे वायर की, या कार बना देते थे वायर की. So that kind, you're not getting the surface there, you're just getting the edges there. You're not getting any surface. So that is a wireframe model. So it is constructed using edges and projected lines and curves, but not the surface. So it's the simplest form of modeling for computers, and it is used for CAD CAM systems. CAD is computer aided design, and CAM is computer aided manufacturing. So basic wireframe entities can be divided into analytic and synthetic entities, but we'll not do into the details. We'll just know the basic part, what is wireframe modeling. So this is wireframe modeling. Here the hidden lines are not removed. That means the other side lines are also mixed up here. It's not hiding any hidden lines. So like, what is hidden line? Let me explain what is a hidden line first. Now suppose you have suppose a solid frame is solid plate floor is there, and maybe you have these kind of lightning holes and manholes here. Okay. Now this is your lightning hole and manhole. I'm just explaining what are hidden lines. So suppose a stiffener is fitted here. You have a stiffener fitted here. Okay. So the stiffener is actually here. So it is not hidden. But suppose the stiffener was on the other side. Now you can see the stiffener here. But suppose the stiffener is on behind this. अब उसको कैसे प्रोजेक्ट करेंगे? So उसको प्रोजेक्ट करने के लिए we have to have a hidden line. So that means we make dotted lines here. इधर dotted lines हम कर रहे हैं. Now that is a hidden line. Now this dotted line shows that a structure is behind this. So stiffener is behind this. That is a hidden line. But suppose we have to show a girder, that is not hidden line because the girder is passing through and through. तो गर्डर जो है वो हिडन लाइन नहीं है, गर्डर तो आपका ऐसे जा रहा है ना, गर्डर इज कंटिन्यूस। तो गर्डर जो है फॉरवर्ड टू आफ्ट आपका कंटिन्यूस जा रहा है, तो इट इज नॉट हिडन लाइन क्योंकि यू कैन सी इट इन फ्रंट, लेकिन ये स्टिफनर इसके पीछे है, दैट इज हिडन लाइन। हैव यू अंडरस्टूड नाउ व्हाट इज हिडन लाइन? समझ आया कि नहीं? हिडन लाइन क्या है? या इसको दोबारा बचाएं? शुड आई
ये
टेल
सर
इट
समझ आ
अगेन?
गया। नो सर,
समझ आया? नहीं आया समझ? किसको नहीं आया? कितनों को
आ गया
नहीं
सर।
आया? आ गया, ठीक है। क्योंकि कई बार आता है व्हाट इज हिडन लाइन रिमूवल, तो सरफेस मॉडलिंग में हिडन लाइन रिमूवल होता है, लेकिन वायरफ्रेम मॉडलिंग में हिडन लाइन दिखता है, उसको रिमूव नहीं करते। सरफेस मॉडलिंग में हिडन लाइन गायब हो जाता है क्योंकि सरफेस दिखाई दे रहा है। इन वायरफ्रेम में hidden line is not removed, it is still there. So I just wanted to explain what is hidden line, because unless you learn it, you don't understand it, फिर आप क्या करोगे, उल्टा सीधा लिख दोगे, वो नंबर भी कट जाएंगे। कंस्ट्रक्शन में थोड़ा सा है कि ध्यान लगाना पड़ता है, नहीं तो गड़बड़ हो जाता है, रट्टा मारोगे उल्टा लिख दिया जीरो हो जाता है। Now what is the advantage of wireframe model? The first advantage is that you can quickly and efficiently convey information than multi-view drawing. You don't have to draw a lot of things, you can just make a wireframe model and set. So the only lines seen here are intersection of surface, and this can be used for finite element analysis. So when you have computer numerical control machines, so wireframe models can be input for CNC machines to generate simple parts. From this wireframe modeling, you create surface modeling, and you can create solid modeling or higher order modeling. So wireframe modeling is the simplest form of modeling, and from that information you can create surface model, solid model or high frame model. The last advantage is it doesn't require too much of memory space. So आपका इतना इसका जीबी नहीं होगा, इतना जीबी नहीं होगा, क्योंकि अगर सॉलिड फ्रेम मान लो, हो सकता है वो एमबी बहुत ज़्यादा हो उसका, केबी में आ जाएगा, ये किलोबाइट्स में आ जाएगा, वो सरफेस मॉडलिंग एमबी में आएगा, और वो गीगाबाइट में आ जाएगा सरफेस मॉडलिंग, वो ज़्यादा स्टोर करता है। बट wireframe model, the memory required will be quite less, so it is easy to store and display. Now what are the disadvantages of wireframe modeling? Is these lines are geometric entities, and these are curved in 3D, and your volume or surfaces are not defined. So for defining surface you have to go to surface modeling, and for defining volume you'll have to go to the solid frame modeling. So sometimes if you cannot visualize, then it will be very hard to interpret wireframe modelings. And also the hidden lines are not removed. If you see this diagram, so these lines can be seen, the other side lines also can be seen. See, two lines are seen. So one line is of this, other line is of that. Stop port side also. So hidden lines, you can see light lines here. So those port side lines are also complicating this issue. Those are not erased. If you see the surface modeling here, now you can't see any lines here only. So there are no hidden lines here. Actual lines and hidden lines are not there because they are plain surfaces shown. So for complex items, the result can be jumble of lines, which is impossible to determine. So simple modeling can be made with wire lines, not complex modeling. Now you can't computate the information with the lines of intersection between two faces of intersection. So you can't determine the surface area or volume with wireframe modeling. Now we come to surface modeling. So in surface modeling, your surface features like your edges of the object are clear, and the part of the curve with parametric technique is clear. So these are edited as single entities, and surface modeler represents the skin of the object, and these skins have no thickness of material type. So you can see the surface, but you can't get the volume of the surface because you don't have the thickness of the surface. So the advantages of surface modeling is it eliminates ambiguity and non-uniqueness present in the wireframe model by hiding lines not seen. So your hidden lines are removed here. Render the model for better visualization and presentation, and the objects are more realistic. It provides surface geometry for CNC machining or CNC's computer numerical control machines. And it provides the geometry needed for mold and die design. It can be used for designing and analyzing complex free-form surfaces, which can be ship's hull or airplane fuselages or car bodies, which are complex, like Lamborghini car. That designing अगर करना है तो उसको भी surface modeling से design करेंगे, not wireframe modeling. So surface properties like your roughness, color, reflectivity can be assigned in demonstration, but the thickness of surface is not assigned. Disadvantages: it does not provide information about inside of the object. It's a complicated computation depending on number of surfaces. So that's your surface modeling. Now we come to solid frame modeling. So solid frame modeling is representation of solid parts of an object on your computer. You can move around that object in all sides and see. कोई ऑब्जेक्ट है उसको सारे एंगल से आप देख सकते हो अगर सॉलिड फ्रेम मॉडलिंग है. So it is made, a typical geometric model is made up of wire that shows object in form of wires. And this wireframe can be 2D, 2.5D or 3D. 2D is like in a page, 2.5D little projections are there, and 3D is they can see from all the sides. So providing surface presents the wire in 3D view, makes object more solid on computer screen, and that is solid modeling. So कई बार पिक्चरों में दिखाई जाता है ना कि वो 3D मॉडल को देख रहे हैं सब एंगल से. So that is solid modeling. So advantages here is CAD software, that is computer aided design software. This will help the designer to see the designed object as it is a real manufactured product. So he doesn't have to go to the factory to actually see, he can see the design in his computer. It can be seen from various angles and directions and views. This helps designer to be sure that the object looks exactly as he wanted it to be. Plus, it gives additional vision to the designer on what will be your changes which can be done to the object. देखते हैं इसका 2-4 मिनट हैं तो. So any questions on modeling? Any questions you have? Nothing. Actually सारी visualization है और कुछ नहीं है. All this is all visualization which you are supposed to know कि visualization कैसी है, बस और कुछ नहीं है.
सर क्वेश्चंस आते हैं इसमें से?
क्यों नहीं आते हैं भाई, आएंगे.
कैड कैम तो आता है सर, शॉर्ट नोट्स.
कैड कैम भी आता है, मॉडलिंग का भी आ चुका है पेपर में, पहले भी मॉडलिंग आ गया है. कैड कैम है, मॉडलिंग का, रेंडरिंग का आ सकता है, हिडन लाइन रिमूवल का आ चुका है, काफी चीजें आ चुकी हैं भाई, इसमें बहुत आ चुका है। न्यूमेरिकल कंट्रोल का आ चुका है, नेस्टिंग का आ चुका है। ये क्या खुल गया? वैसे घबराने की आपकी बात नहीं, पेपर तो आपका, क्योंकि ज्यादातर आपके स्टेबिलिटी के क्वेश्चंस हैं, तो आपको डिफिकल्टी नहीं आनी चाहिए, क्योंकि आई थिंक 3 क्वेश्चन तो स्टेबिलिटी के आ जाते हैं, चौथा तो न्यूमेरिकल्स आ जाते हैं, 3 न्यूमेरिकल्स आर देयर, और आई थिंक 1 and 2 मोर थ्योरी आर देयर इन स्टेबिलिटी। बाकी 4 क्वेश्चन तो मेरी तरफ से आते हैं, दैट इज 3 फ्रॉम शिप कंस्ट्रक्शन, 1 फ्रॉम लोड लाइंस। तो लोड लाइंस में भी आपका कंसेप्ट्स आ जाते हैं, आपके टाइप ए टाइप बी वाले हैं, कन्वर्जन आ सकता है, देन उसका एक्सक्लूडेड इंक्लूडेड वाला है, उसका डायग्राम आ जाता है। सो यू हैव अ चॉइस, तो उसमें प्रॉब्लम नहीं आनी चाहिए। यू शुड नॉट हैव अ प्रॉब्लम इन दिस पेपर। पासिंग इज इजी है, ऐसा कोई डिफिकल्टी नहीं है, नथिंग डिफिकल्ट इन दिस पेपर।
ओके।
ये लिंक आप बाद में देख सकते हो, 3D ऑटो कैड जो है 12 मिनट का है, ये भी देख सकते हैं। चलो देख लो, थोड़ा सा 2 मिनट है तो देख लो। इसमें साउंड पता नहीं क्यों नहीं आ रहा है, साउंड है इसमें, लेकिन पता नहीं क्यों नहीं आ रहा है इसमें, एमएसटी की कुछ प्रॉब्लम हो जाती है। नाउ दिस इज अ सॉलिड फ्रेम मॉडलिंग, इफ यू सी द फुल थिंग इज सॉलिड फ्रेम मॉडल, यू कैन सी द डेप्थ एंड ऑल। तो अगर मैश ही दिखेगा, सो दैट इज नॉट अ सॉलिड फ्रेम मॉडल, सो दिस इज अ सॉलिड फ्रेम मॉडलिंग। नाउ दिस इज वायर फ्रेम मॉडलिंग, अगर ये देखो, this is wireframe modeling. You can't see actual surface and you can't see actual thickness. So you can you have the software for converting wireframe to surface modeling or solid frame modeling. So that software is an AutoCAD that is utilized for all these things. ये अलग अलग आपके सेक्शंस है, इतना डिटेल में नहीं जाओ, बढ़िया यू शुड नो कि भाई you have AutoCAD for making all these designs. तो आप मैश डाल सकते हो और उसको सरफेस बना सकते हो, ऑल दोस थिंग्स यू कैन डू। ठीक है, फिर आपका टाइम हो गया है, नॉट टेक मोर टाइम, आई हैव अ नेक्स्ट क्लास आल्सो। तो वीडियो आप देख सकते हो आराम से AutoCAD 3D, अदरवाइज टाइम मिलेगा तो आपको अलग से दिखा देंगे, शो यू सेपरेटली। ठीक है, सो विल टेक अ ब्रेक नाउ विच यू रिक्वायर नाउ। लंच के बाद तो ब्रेक बहुत जरूरी हो जाता है। हैव योर टी एंड ऑल and prepare for the next class. Okay then. Bye bye.
बाय सर, थैंक यू।
Bye bye.